In this next example, we're going to have a bag containing marbles, but it's going to be a little bit different than the example we looked at previously because there's not going to be just one of each color. So in this bag, there's going to be 4 red, 1 white, and 5 blue marbles. So we're going to pull 2 marbles from the bag, and we're going to find the probability of each of these following scenarios, looking at what would happen if you replace the marbles in between the pulls, versus in part B, we're going to find if you do not replace the marbles in between the 2 pulls. So let's find the probability of pulling a red marble and then a blue marble, and we'll initially look at this with replacement. Alright, so the probability of red and then blue. So we need to get an idea about how big our sample space is. So if I have 4 red, 1 white, and 5 blue marbles, I have 10 marbles total. Alright, so what's the probability that the first marble we pull is a red marble? Well, out of the 10 marbles, there are 4 of them that are red. Alright, so we pull the red marble out, and then we're going to replace it in the bag. Now let's go to the second stage. What's the probability that the second marble is blue? Well, at this point in time, there are still 10 marbles in the bag since we replaced that first marble, and then 5 of them are blue. So the probability that the first one is red and then the second one is blue will be 20 out of 100, which simplifies to 1/5. Let's take a look at the same scenario, but now without replacement. So probability of pulling a red marble first and then a blue marble second. So the probability that the red marble is first. Well, for the first pull, you've got 10 marbles in the bag. 4 of them are red. Second stage of this experiment, the probability of pulling a blue marble out. Now at this point in time, we assume that the red was already pulled out and set aside. So we only have 9 marbles in the bag. So that'll build my denominator. And out of those 9 marbles, how many of them satisfy the condition about being blue? 5 of them do. So then that would build my numerator. So the probability that the first one is red is 4/10. The probability that the second one is blue is 5/9. So if we multiply, we get 20 over 90, which simplifies to 2/9. Okay, so on this one we had to be a little bit more careful on that second stage in terms of getting those counts. So let's take a look at this next scenario. So you get no red marbles. So this will then be the probability that you get no red, which means that you want the first one to not be red, and then you want the second one to not be red. So let's initially do this with replacement. Alright, so on the first pull, how many marbles are in the bag that are not red? Okay, so that would be 5 blue and 1 white, so there'll be 6 marbles that are not red out of the 10 marbles total. Now at this point in time, since you're doing this with replacement, the probability that the second one is not red is also 6/10. Right, it's like the experiment reset itself. It still looks on the second stage like it looked on the first stage because the marble was returned. So then this probability would be 36 out of 100, or simplified 9 out of 25. Now let's take a look at the scenario without replacement. So the probability of not red. So that'll be the probability that the first one is not red times the probability that the second one is not red. The first one not being red. Well, at this point in time there are 10 marbles in the bag and 6 of them are not red. When I go to the second stage of the experiment, the first stage has already happened. So we've already pulled a not red marble out of the bag and we set it aside. It was not returned to the bag. So we only have 9 marbles in the bag at this point. and how many of them are not red? You have 5 not red marbles that are left. So the counts change both in the denominator and the numerator. If we multiply across, you get 30 out of 90, or 1/3. Okay, so the ones that are dependent are the ones that are maybe a little bit more tricky. For independent, because the experiment resets itself, it's kind of like everything goes back to the beginning, and you don't have to think about what happened on a previous stage. All right, for the next one, what happens, or what's the probability that you pull at least one blue marble? So for at least probabilities, we had found that one way to approach it, the probability the event happens at least once. So this means it could happen once, or it could happen more than once. So there's usually a lot of different outcomes that are in this event. So the easiest way to do it is to think about who is not in this event. That would be then the event does not happen. So we're going to take this approach on this problem. And we're going to work through this with both replacement and then not replacement. So maybe let's go ahead and label these. That was the replacement scenario. This is the marble is not replaced. Let's do it again down here. All right, so the probability of at least one blue. All right, so this is going to be equivalent to doing 1 minus the probability of no blue marbles on either of the two poles. So this is going to be very similar to how we did the no red marbles, except the counts are going to be a little bit different just because we're looking at a different color. So let's go ahead and find the probability of no blue marbles. So what's the chances on the first pole you do not get a blue marble? Well, coming up here you have, it looks like 5 marbles that are not blue out of the 10 total. And because this is going to be with replacement, on the second stage you still have 10 marbles and you still have 5 that are not blue. So going ahead and computing this, so this will be 1 minus, multiplying those fractions together, that'll be 25 over 100. So this will be 75 over 100, or 3/4. So that's with replacement. Now let's take a look at this without replacement. So the setup is going to be the same, so the probability of at least one blue marble is going to be equal to 1 minus the probability of getting no blue marbles. So let's find the probability of no blue marbles. So on the first stage you have 10 marbles in the bag. You have 5 of them that are not blue. At this point though, because this is without replacement, on the second stage you only have 9 marbles in the bag. And then in terms of marbles that are not blue, you only have 4 of them left at that point. So multiplying those fractions together, you get 20 over 90. Doing the subtraction then, you would get 70 over 90, or 7/9. All right, last one. What's the chances of getting 2 white marbles? So for part A, this is going to be with replacement. So the probability of getting white and then white again. So the chances that the first white or marble is white, you've got 10 marbles in the bag. Let's come up here. You've got 1 of them that's white. On the second stage, you still have 10 marbles in the bag, and 1 of them is white, because this is with replacement. So that white marble that you pulled on the first draw went back into the bag got shaken up again, so you still have 1 white in there out of 10 marbles total. So multiplying through, you'd get 1 over 100. For part B, this is without replacement. What's the probability of pulling a white and then a white one again? Now on the first pull, you've got 10 marbles in the bag. You've got 1 of them that is white. On the second stage, that's assuming that this first stage has already happened, so you've already pulled a white marble out. Right? So that first stage has already happened. So you only have 9 marbles in the bag at this point. Out of those 9 marbles, how many of them are white? Well, that first stage already happened. You already pulled this white one out on stage 1 before you got to stage 2. So if that white marble is already out of the bag, how many white marbles do you have left in the bag? None. All right, so this numerator would be 0. So then this probability is 0. It's going to be an impossible event to pull 2 white marbles out of the bag when you're doing this without replacement. And that should make sense because you only had 1 white marble in the bag to begin with. So the only way that you could pull out 2 white ones in a row would mean you have to have at minimum 2 white marbles in the bag. In this case, you only have 1, so this can't happen. All right, so that probability is 0. Now, your book does not show trees like this, but I want to show you how you can model this scenario with these marbles in the bag. Even though there's more than one of each type, you can still model with tree diagrams what this looks like with replacement or without replacement in order to get these counts. And for some people that are more visual, they like being able to draw trees like this. Now, you don't necessarily have to. We answer all of these questions just by thinking about the different counting arguments. But let's go ahead and take a look real quick at what a tree would look like. So first off, I'm going to do the tree for with replacement. Now, on the first pull, you could either get a red, white, or blue marble, except there's more than one of some of these colors, right? So we don't actually have to draw a separate branch for each color. We don't have to call them like red 1, red 2, red 3, and things like that. What we're going to do then is on the branch, we're going to put the count of how many satisfy having this outcome. So there are 4 red, 1 white, and 5 blue marbles. So we're just going to put those on the branches, and that's how we're going to keep track of our counts. Now, if this is the tree with replacement, that means on the second stage, I still have red, white, and blue, red, white, and blue, red, white, and blue. And then because the marble is getting replaced, the counts on these on the second stage don't adjust. So I would still have 4 red, 1 white, and 5 blue marbles if a red marble was pulled initially, because that red marble went back in the bag, so that count doesn't get adjusted at all. So I can put 4 red, 1 white, 5 blue, 4, 1, 5. So if I want to find, for instance, the probability of, let's come back up here, a red and then a blue marble. All right, so to build the denominator, there would be 10 times 10 or 100 outcomes possible. So that builds the denominator of the 100. And then that first one, which was a red and then a blue, so red and then blue, that would be right here. To get the count, you would multiply the numbers along the branches. So this red had 4, that blue had 5, so 4 times 5. There are 20 ways that could happen. And notice that that is the numerator that we came up with up here. Okay, so you can use this tree then to kind of visualize some of the outcomes, and then you just put the counts along the branches. Now let's take a look at what this tree would look like without replacement. Now, without replacement, there are 10 marbles for the first pull, but once that marble comes out, there's only 9 marbles for the second pull, so there's only 90 outcomes total possible on the without replacement scenario. So if you look at most of our examples, the denominator was 90 before we simplified it. So the building of the tree is going to look the same. So red, white, blue, and then I'm going to do the second stage. Red, white, blue. All right. So let's go ahead and put the counts on the branches. Now for the first stage, there are 4 red, 1 white, and 5 blue marbles. So the kind of the beginning of the tree doesn't look any different than this one over here. This one we have to be more careful when we get to the second stage. Because the marble's not being replaced, counts are going to shift. So let's go to the second stage up here. So how many red marbles do we have in the bag, assuming that a red marble was already pulled? So if a red marble was already removed from the bag, you only have 3 red marbles left. All right, so that count shifted, but at this point in time you still have the 1 white and the 5 blue marbles. All right, so those counts don't adjust because you haven't touched those marbles. All you've done is removed a red one. Now let's come to the middle branches. So at this point in time the white marble is removed, so there will be no white marbles left, so I can put a 0 on that branch. There are still 4 red and 5 blue. On the bottom set of branches, that was where a blue marble was pulled, so the blue branch is going to have its count dropped, but at this point in time there are still 4 red and 1 white. Alright, so if I want to find any probabilities, I would just reference these appropriate branches. So let's take a look at that first example, which said a red and then a blue. So red and then blue was right here. So red and then blue was right here. So to get the count for that one, it would be then this 4 times that 5, which is 20, which is the numerator that was built in that scenario. But notice now this tree becomes helpful for instance, let's take a look at this one. That's the probability that neither marble was red. Okay. So you want, out of your 2 pulls, neither the first spot nor the second spot to have a red marble. So how could we use this tree to find that probability? Well, so let's start going through the branches and see which ones we want to count. So we don't want to count this one because this actually has red in both spots. This one would have red in the first spot. That one would have red in the first spot. So we don't want any of those branches. This one would have red in the second spot, so we don't want that one. This one has no reds. Okay, but that doesn't generate an S for any count because there's no way that that could happen. This has no reds, so that we'll just multiply those numbers. So there's 5 ways we get no reds. That would be white and then one of the blues. Coming down here, we don't want to count this one, but this one would work, so we would multiply those numbers together. Okay, that would be a blue and then a white. There's 5 ways that could happen, or we could get a blue and then another blue. There's 20 ways that could happen. So we would just add up all these numbers. All of these would be scenarios that have no red on neither the first pull nor the second pull. If you add all these up, you get 20 plus 5 plus 5, which is 30. And that's the numerator we got right here. So it's just a slightly different way of approaching the problem. This approach is a little bit more visual, and it has all the counts kind of in front of you, so that way you could be a little bit more careful about which outcomes you want to pull for your event.